Hello, everyone. So, welcome in our first ever Mitsubishi Electric podcast. Today and in the coming months, we will be talking about lots of topics, lots of trends in the related to digitalization, digital transformation in manufacturing. My name is Piotr, and you can also call me Peter. I'm sure it will be easier for some of you. And I will be host of this event. And today we actually will be discussing current situation in the automotive industry. So today I have a very special guest. It's Lukasz Majewski, who is our expert in the automotive industry. He is our vertical director for this business. And he will be sharing his insights with all of us. So Lukasz, are you excited to be the first guest?
Thank you, Piotr, and good morning, everybody. I'm very happy to be here with you and to have the chance to discuss what is changing our automotive EV industry. Because as you mentioned, there are many things ongoing and a lot of topics that we can discuss together.
Yeah, I believe I think digital transformation was a topic that we were discussing for the last, I don't know, maybe even up to 10 years. And we know that gradually automation processes in the manufacturing. But it seems that these days we have actually a real chance to tackle big problems in this industry. So I hope this conversation will be interesting for all of you. I think it's a very exciting 40 minutes where we will be talking with Lukasz about those points. And after those 40 minutes, we will have a chance for Q&A session. So if you have any questions to Lukasz or to me, please feel free to post them in our chat window. In the chat, you can also find the questionnaire. So if you want to stay closer with us and if you want to share some insights, please open the questionnaire in the meantime. But let's start. So I think kind of personal story. So I was going to change my company car recently. And we went to one of the car dealers and they said something around 12 months of waiting time. And another car dealer said 18 months. So would you say this is a normal situation in this industry these days?
Yeah, thank you, Piotr. I think you are not alone in this situation and not the first to hear that the delivery of cars is now longer than what we have seen in the past. This is mainly due to the challenges our industry is facing. Some of them started already a few years ago with the COVID crisis that were responsible for the shutdown of some factories, manufacturing processes and so on. And this contributed to a reduction of the number of components available on the market. And consequently, our automotive industry were not able to deliver, all the cars that they promised in the normal period of time, we can say. Mm-hmm. So, this is one, I would say, crisis from the COVID. Now we have another also in Ukraine. So moving one to another. So we have growing energy costs that also contribute to more, I would say, challenges for the automotive industry. And besides those crises, our also industry is facing other challenges, especially about the sustainable manufacturing. They have big pressure from the society to contribute or to minimize the negative impact on the environment. So what they can do to reduce the negative impact, we are talking about CO2 emissions. That's one of the topic. Of course, we are looking at what will be used in the cars, like electric cars or IC and so on, but also on the manufacturing side. So how automotive industry can reduce the CO2 emissions from manufacturing processes. That's also a key topic. And beside the pressure they have from the society, they also have pressure from regulations, because if they do not meet with their targets, they will face big penalties. They will have to pay very important penalties. So it's not only, to appear as green, but also there will, I would say, financial pressure. So it's very important topic. Still talking about this sustainable manufacturing, what we see and what should be, I would say, a new trend is to reuse, also repurpose and recycle, so natural resources, so minimize waste, pollution, and so on. We see that already some car makers started to do so, that they adapt their factory to be more like recycling, etc., reuse the energies and so on.
So we discussed, just to sum it up a little, disrupted supply chains, which is an ongoing issue for a long time, and then of course a need to be green. Is there any other trends that we should know about?
I think we can mention a third one about the changes in customer behavior. This is also one important because it will definitely drive our automotive industry. For example, if we now are buying a car, in the past, I would say that you were going to a dealer, you were selecting your car on a catalog, discussing with somebody and so on. And today we see that more and more you have interfaces, web-based interfaces. You can easily purchase a car using a mobile phone and so on. Right. That was maybe not possible 10 or 15 years ago, but currently this is, I would say, a normal buying act. So, and this is kind of, I would say, easy way to purchase. Right. It's also changing how automotive industry should adapt. And also talking about this, we can add about the customization and personalization that since we have the possibility now to, adapt, to select what we want on the car, to have this option, this color, this and this, we know that those cars are no longer all the same. We have more and more different cars. And this also drive the manufacturing because the manufacturing should be able to adapt quite quickly to meet with the customer requirements.
And now when it comes to the actual manufacturing process, so now we understand what's going on. But when I think about the production processes in automotive industry, I have a feeling that those processes are already very efficient. So we have very modern technologies implemented in our, let's say, customer sites and so on. And for example, when we are discussing these trends, one obvious thing that we could start optimizing is, for example, energy use. But do you think that there is anything that can be done about energy in automotive?
That's a good comment because, as you said, in automotive industry, there's a lot of already modern equipment. So we cannot say that it's industry that it will be modernized in a few years from zero, to completely new. So there are already modern equipment, but having those modern equipment will also allow us to do something that maybe not all customers are already paying attention. I think most of them are paying, but it's not fully, I would say, discovered. And this resource would be the data that so they can collect from the machine and so on, how they can use it to improve their manufacturing processes. And we can talk about for example, EMS, energy management system, because you were talking about energy. So what is important for our industry is to collect this data, but every kind of data, not only electricity. I mean gas, water, air, everything. Also the energy they produce and so on. But it's important that they have a standardized way to collect this data, so they can easily compare from one machine to another, and also from one factory to another. So it has to be standardized. And second important point is to use open standard protocols, do not be locked with any specific company and so on. And with having those two, I would say, what I consider as mandatory points, will allow them to have better insights on the machine. And why I'm talking about better insights? Because as long as you have this data, you can build different dashboards. So you can see, for example, how much electricity have been consumed by this machine, by this equipment, and so on. So you can easily have those information. And you can, as I said, so have it from machine to production line, factory, and so on, every level. In addition to this, so energy, electricity, we can also generate carbon reports to see also from where are coming the CO2 emissions. To also address this topic as an important one. In addition, you can also use this data to detect, for example, abnormal use in the machine, so like kind of predictive maintenance. And finally, I think that as long as you have this data, we can customize and have everything integrated into one interface. So it means that you don't need to switch from one screen to another. You can have everything into one interface, like, kind of real-time information, KPI, Sankey diagram, and so on. Right. Everything will be integrated, so it's easy also to manage, faster and simpler for everybody.
Okay, but so now we have discussed, how the proper management of the data can change the situation. Yeah. So you have all this information somewhere in the factory, but actually by proposing a proper BMS, you are able to actually create a completely new value out of this data. But how about this advanced technologies of processing the data? So I have an example from our own factories from Japan. Yes, of course the process is a bit different, but our Japanese factories, of course, they are concerned about the energy costs because in Japan the costs of energy are huge for the last 10 years and so on. So they actually implemented a AI technology in order to monitor the processes. So the AI is able to identify some places and targeted parts of the application when actually the energy can be reduced. Yes, so this is, I believe, going one step further with this technology. The solution is called EcoAdviser, and this is something that we have created for our own needs in our factories, but now it's a software that can be easily used. But this is Japan, and this is the process is electronic type of assembly and so on. Do we have examples like from your field, from the automotive industry, when the energy consumption was reduced and how this affected the company?
That's a good point about this EcoAdviser. There are other technologies that we used with one European car maker. This technology is Iconic's EMS, or Energy Management System. By implementing this, so we help the customer to identify where the energy is consumed, so on the machine level, application level, and so on. So this was implemented in the whole factory, in whole manufacturing lines, all processes, all machines. So they were able, thanks to this technology, to see what is happening at every moment in their manufacturing process. That was one of the targets. And simply thanks to this capability of collecting data, analyzing, visualizing, we are able to drive significant savings for the customer, working together, because that was also a key of success, is that we worked hand in hand with this European car maker. We, for example, reduced the energy consumption by 40%, 40, and also increased the productivity by 20%. So that was a significant achievement. And last but not least, it was also important for this customer to be able to track what is the energy cost per vehicle. And thanks to this solution, we achieved it. So now they can see what is the exact energy cost for vehicle A, B, C, and D, which of course will vary, depends on the options they may have and so on. The benefits that it brings, so if we talk about the benefits for this customer, so one interesting thing is that we can anticipate the demand based on the production schedule and also weather forecast, electricity pricing. It means, as a simple example, that during the day the electricity price will not be the same, and when the cost is high, you simply reduce your production or even stop. And then when the cost is much lower, you continue your production. In this way, you can simply reduce the energy consumed per car, because, as I said, if the cost of energy is lower, then you know that you can address in this way this topic. And again, that was this track energy cost per vehicle, which is very important. In addition, so about this energy consumption, visualization, and so on, we were able also to reduce the time spent for maintenance and operations using some predictive functionalities. But also, again, having this visualization interface allowed this customer, as I mentioned before, that you don't need to have different interfaces. There is only one, and it's, again, simpler and easier to manage for every management level in this company.
Okay. So it seems like this is a whole complex system that was implemented, and it helped in various ways. So in parallel, like reducing the energy and increasing the productivity. Yeah? So we discussed this situation with energy crisis, and that we seem to have a ways to solve it in some ways, but by implementing proper data management, by implementing some sort of data science strategies and so on. So do you believe that the rising energy crisis that we have right now in Europe, but possibly this can spread over to other regions as well, do you think by this kind of solutions, by this kind of approaches, we can meet, the demand from customers for new cars and, solving all of these challenges that we have discussed in the beginning? Is this, in your opinion, possible?
This is definitely possible. Again, it will contribute to a better competitive position for our customers in the automotive industry. But beside this topic of energy, there is also a second one that is extremely important, even if it does not currently affect directly the cost of the car, it will in the future. It's about the carbon emissions, as I mentioned already several times, that to achieve carbon neutral operations, we have same approach as with the energy. So we need to know where those emissions are coming from. So to collect this data, see where is it coming from, visualizing and so on. And one other important point is to have a real-time monitoring of these emissions. Because to act quickly and to adjust your manufacturing process, you need to have this information in real time. And beside this, as I said, so collection information and so on. After we gathered those data, we can build simple and easily understandable reports. So we can structure and transform.
You said something very important, that the energy crisis is something ongoing. It's very important, but probably sooner or later it will pass. However, the carbon neutrality problems are something that will stay with the automotive industry for a long time. So could you elaborate on this?
Exactly, Piotr. So as I mentioned before, this topic is with us probably for many years, upcoming years. And with the same approach as we have with energy, to achieve the carbon neutral operations, it's important that our automotive industry and the customers can collect also this data, identify where those emissions are coming from. So using real-time data collection, so IoT and so on, to make this collection as simple, as easy, and as transparent as possible. That's one of the points. Having this data in hand, we can elaborate some reporting and measurement comparison and so on. So important is to, as I also mentioned before, to structure and standardize this data in a common, I would say, way how we can read this data. After having all this information, it will be possible and easily identify, as I said, where those emissions are coming from and where we can act to do something and reduce those emissions, because this is the point, how we can reduce. So techniques like abatement or carbon offsetting, we can predict those process emissions and also compensate or reduce the places where they are coming from.
But just to be clear, we will be basically using the exactly same system, exactly the same measurements as we do for the energy systems, but we will be able to utilize it also for the carbon emission management, right?
Yes, exactly. That's the point. Still talking about this iconic CMS solution, that no matter what is your energy, as I said, electricity, air, also pressure, water, carbon emissions, and so on. This will allow you to collect this data, analyze, process, have insight, and definitely act as soon as you identify where you can do something to improve your process.
Right. Okay. Let's leave the topic of energy for a second. Maybe we will come back to this point during the Q&A and so on. However, I think energy efficiency, carbon neutrality is not the only thing that you can do using data, right? So I believe in the industry such modern as automotive, I am pretty sure the use of data science technologies can be implemented in many different ways. I believe strongly. So from your experience and from experience of our customers working with you, where else the data science technologies are used?
You mentioned a good point that it's already in use in some of places in the automotive industry, but it can also be improved or implemented even further. We can mention a few topics like workforce analytics. We can easily identify, for example, where we have the right skills, the right persons are available to make like a repair job or some maintenance or something else. So you can easily match your available competency with your need. I mean, repair, maintenance, and so on.
Right.
So this is one of the points that data science can help improve the operational process of automotive manufacturing. Also coming to operational planning, so optimization, how we can optimize that. So same as before, if we are able to match on one hand, so the competency skills with the needs or repair and so on, we can also do that with spare parts and so on. So you can ensure that you minimize your stock and you only have those that will be necessary for upcoming activity like preventive maintenance and so on. And also, again, having this insight, you can also predict some failures, so you can have spares for corrective maintenance. But again, idea is to minimize and have only those that are necessary. So it's also improving this asset inventory management.
Okay. Actually, when it comes to asset management, I think we have a good example again from our own field, from our own technologies. And we have in our offer, we have this kind of robot arms, which are like standard mechanical arms who are responsible for doing some manipulation in the factory. And we have this special card called Melfa Smart Plus, and it's a small device that we put inside of the robot controller. And this card, basically what it does, it has the embedded AI on board. And this AI technology gives additional intelligence to the robot arm, to this particular robot arm. The way how this works is that instead of using some traditional ways of maintaining robots, like do it in schedules and so on, the robot arm can actually inform about potential issues to the maintenance crew. So the robot itself gets this kind of let's say artificial intelligence type of functionality that allows the robot to monitor itself and provide this kind of insights to the maintenance. Are those technologies something that you have in mind as well for the predictive maintenance?
That's also one good approach still related to data science. So we have many use cases already also existing in the automotive industry. The one you mentioned about predictive maintenance is quite common, but still are room for improvement. That having AI and information about the machine, using some historical data and so on, you can foresee what may be the action you need to perform to avoid any failure or shutdown of your manufacturing process. In addition, we can talk about the process optimization because that's also one important area. We have also one example where one of our customers had some quality issues, and we worked together. And after a few months, so collecting the data, using offline data, real-time data. Again, I insist on this because real-time is extremely important to have real-time data from the machines. Comparing each other, we developed some AI models that allow to identify, for example, the inputs you have, the level they may have, to ensure that your quality remain at the same level.
Right.
So this is kind of process optimization we can have. And finally, I can mention also one else about identification of some potential hidden failures law that we can estimate, again, using this AI, that two variables that has maybe nothing to do with each other, if they are at, I can say, level A and B, we know that they can impact negatively on some machines. And again, this is possible thanks to data science and AI. This kind of correlation that we can do between the data and the level.
Okay.
One other example I like to mention, because this is extremely important and for the EV industry, so electric vehicles. It was some AI that we use for a rotor shaft in EVs. The idea was to monitor some points that we consider as good, so good quality. And the model learned with 99% precision. 99% precision, and we can monitor those data sets, so you can perfectly predict the quality of the rotor shaft for EVs. And this has been achieved in only a few hours, so less than half a day. So you can imagine that if we do that with rotor shaft, then you can do it with any other equipment. But the point is that the quality with current technologies can be extremely easily improved.
In that particular example, the AI basically started from zero. I mean, from having no information up to the 99% precision.
Yeah, that's a good question, and that was the case. So it means that the only point we had is what we consider as a good rotor shaft. So a few data that we consider as good quality, or the one expected, and providing those information to our MyLab solution. It developed its own models, and as I said, with 99% precision.
Okay.
In less than a few hours.
Okay, that's very interesting. So those are the examples that you are giving us. Those are the technologies and approaches that are already used, right, in the automotive. So many of our customers have these advanced data management systems for energy or otherwise, and they are already using the AI, for example, to predict this kind of failures of their equipment, whether it's our equipment, which is manufacturing equipment, or is it the actual product, yes? So this is already ongoing. From your experience, and how do you feel for the automotive industry, what's the next step? Where the industry will be moving, especially when it comes to data science topics?
That's an excellent question, and I am more than convinced that the next step will be the lights out factory, so next level automotive manufacturing. We're talking about autonomous automotive manufacturing. There are a few examples like self-programming robots and cobots. So currently that there are some, I would say, legal restrictions to do that, but technically, technologies are available to do that. So you can have robots that will adapt their path automatically by detecting, some obstacles that they may have. They will avoid, and so on. So this is self-adaptative robots. You don't need to program anything else. You just provide the point A, point B, and everything in the meanwhile will be managed by this technology. So this is already something available that we can implement. Other example will be, I think, about smart AGVs, so intelligent AGVs that can autonomously navigate inside the factory. So principles are the same as those self-adaptative robots I mentioned, that we define point A and point B, and in the between, everything will be managed by those intelligent AGVs. So they can adapt their path, change if needed, stop, or go back, and so on. Again, fully autonomous AGVs. We were talking about predictive maintenance, corrective maintenance, and so on. But I think that the next step will be the prescriptive maintenance. And again, if I come back to this data science, if we have this data, we can somehow have a prescriptive maintenance. So we can implement digitally or virtually what may be this maintenance and so on, and see what may be direction, etc. So you can have different scenarios, and again improve your maintenance. One other step will be the self-adapting or adjusting manufacturing process. This is one important point, because I mentioned before that we worked for this quality improvement process with one of our customers, and this is technology that we have right now is extremely powerful for several reasons. As I mentioned, that we can collect this data, apply some AI, so define some models, and so on and so on. What is extremely powerful here is that you can feedback the result inside the machines, which basically means that the machine will automatically collect data, analyze, and correct something on the machine if necessary, without any human, intervention. Of course, if you need, for example, a process engineer to confirm that, okay, you can make this adjustment or modification in the process, you can have like a validation. But again, technically speaking, this is currently feasible. We can do that. So this I think would be the next step to have like a fully autonomous automotive manufacturing.
And all using the data, the power of data, I guess. The data that is already in the factory, right?
That is already in the factory, or that we may also collect, because we know that those data is here, but at the end we need to somehow extract this data from the machines. And then what you do is important with your data, because if you have only data, but depends on your analysis and so on, it will also change the outcome. Right,
of course.
And again, based on our experience, what we did with our customers, we think that this is the direction automotive industry should undertake to become even more, I would say, profitable and interesting for all of us.
Okay, clear. Okay, so I think we are almost at the end of the discussion. We will answer a couple of questions definitely in a second. You still have chance to ask them in the chat. We have a couple that we can explore in the couple of minutes. But maybe a small summary of what we have discussed. So it seems the data manipulation, the way how you use it, and what kind of insights you can get from it could be the game changer for the industry. Yeah, and we have a couple of examples, which was the energy efficiency, and later on developing on the energy efficiency, that's the carbon neutrality that can be handled by that sphere of factory. And then moving step by step, we are arriving at the possible future, which is not that distant. And that's the future where the production processes are very autonomous. So you will have very flexible operations, and the machines will be probably able to take decisions by themselves. Do you think that's how we can wrap up this conversation? Do you believe this is exactly what we believe about the automotive?
That's exactly the point, Piotr, that this autonomous manufacturing, as you mentioned, is probably not as far as we expect. I think that currently there may be some limitations, because we still may not accept a machine to take the decision on our behalf. But going, above this obstacle is, in my opinion, the last step before implementing a almost fully autonomous manufacturing process for the automotive industry.
Okay, very good. So I believe we have time for a couple of questions. I can see them on the chat. However, before I go to the chat questions, I wanted to ask a follow-up question about the example that you gave about the rotor shafts for the EVs. Yeah? So you said this was very important to gather real-time data from that process. But it seems like when you are gathering the real-time data, there will be a lot of it. Yeah. So is this something that the prediction model would be taking all of the information that is generated every millisecond, or will be there some sort of a filtering that maybe not all of the information is necessary? Do you know, like in this particular process, how this was done?
Yes, so yeah, I can explain this process. So as I mentioned before, we started with several data about this rotor shaft that we consider as a good quality. But thanks to this model, thanks to this AI, the models that were predicted only kept, I think, 2, 3, 4 data. So it was not as much as we started. I mentioned before that the interesting thing about this technology, about this AI we have, is to establish this correlation between two variables that for us may be, there may be for us no link, no relation. And thanks to this model, we will establish that. So yes, as you mentioned, real-time collection is important, because if you don't have this real-time collection, but if it's offline or something else, you lose a lot of minutes, even hours, and then it means a lot of money.
Right.
So the faster you see it, the faster you react, you will have less, you will spend less money on that, you will lose less production, and so on. So this is why real time is a key in those kind of processes. So to conclude on this, yes, we started with many different data, but after this model has been established, we only limited it to a few.
Right.
But this is this model that gave us this relationship. We're not able, of course, humans are smart, but we're not able to establish so quickly this relationship. And I insist really on this. In only a few hours, it has been achieved. Yes. Only a few hours, less than half a day.
Yes.
It's extremely powerful.
Yes, that is definitely true. There is one question on the chat which is related to detecting abnormalities, and the question is also, okay, you detect the abnormality, and whether you are able or not to take immediate action. But I believe the question is the actual question is whether this immediate action can be done by machine itself. I think you elaborated on this already, but could you also give us insight how often this is already used? Because it seems for me that is a bit challenging to achieve and also could be dangerous. So is this often used, this kind of immediate action taking?
Okay, so about this abnormal use. As I mentioned, as long as we have access to this data, you can establish the models and identify what is the correct, I would say, operations of the machine. Then you can quite easily define what is an abnormal use. Because again, on the machine, you may see, simply a variable that is moving. For us, it will be useless, but the machine will tell you that this is a potential problem. If we do not act now, then there will be an issue. This is about this detection. Now, when it comes to implementation and how often is it used in the industry? I mentioned before that there is still, what I see from my experience, a psychological obstacle that our executives from automotive industry, they really don't want a machine to take this kind of decision. To say, okay, I see this application is not working correctly, then I will adjust it and implement the needed correction immediately in real time. Technically, it's feasible. As I said, we did it. It works. But still, there is this kind of obstacle that who will be responsible in case something happens, because this may happen. The machine adjusts itself. You have somebody working on it. There may be an injury and so on. So there are still, some kind of obstacles. But again, technically, this is something that we can already do right now with our technologies.
And I think especially with actions that are not causing that much, process differences, right? So like a small corrections that we can do immediately. I believe this is already possible and being implemented. Yes.
Yeah, exactly. Let me add one thing here, because as long as the process is isolated, and you know that there is no interaction with human and so on, and you remove those kind of obstacles that may have, this is, I would say, perfect application where you can use this kind of technology.
Okay, clear. There is a very interesting question actually about your last point that you were making about the autonomous manufacturing, because we see some examples already of the pilot projects being made. Actually, we have one as well in our factory in Japan. But the question is when do you expect this kind of fully autonomous systems will be implemented? I mean, for example, you said that the factory that you can just shut off the lights and just leave the factory. Of course, it's an exaggeration, but that's more or less what autonomous manufacturing means. When do you expect these systems will be implemented to its full potential?
That's a very good question, and probably difficult to predict to 1 or 2 years. But I believe that between next 5 and 10 years, this is the direction we are going, and we'll be probably able to have this kind of, as you said, lights out factories. Maybe it may be exaggerated, but if we compare with other industries, we know that some are already almost fully autonomous. There are only, I would say, a few applications that require human intervention and so on. So it's possible. We are going here, and I think between the next 5 and 10 years, we will reach this level.
As quickly as 5 to 10 years, you believe?
Again, as I said, those technologies are currently available. The main obstacles we can see are from a regulations perspective. As I was talking about the safety, this is an important one. But those, I believe, with new technologies coming, like safety cameras and so on, will be solved. And one, I would say this will be more difficult to overcome is how people are reacting to that. Would you accept that your factory is fully autonomous?
Yeah, of course not. But actually, yeah, the question also includes this point that not taking into account process control specialists, which of course they will be necessary to be there, and they will be always, being in charge of whether this is everything is under control. Yeah. So of course, switching off lights in the factory is exaggeration.
When I say lights out factory 5-10 years, of course, you are right that. This is exactly the direction we are going, but you always need some process, engineers, those that know how to make, some modification and so on. Those will be always necessary.
Yes.
I think we will not replace, 100% of the people by only machines and so on. But when I say lights out factory, it's really the direction and the kind of applications that will autonomously and self-adapt to the process, change, and so on.
Okay. Another question related to autonomous manufacturing, and I can only suspect that this is related to that. And the question would be, how would, for example, the robot that is moving on AGV, which is very flexible, can move around the factory, how will those robots know which product to manipulate? Which part of the production process that they're responsible for, and where the workload is placed? How will they be finding this? Yeah? Any ideas? Because I believe that the ability to provide coordinates for the workload in real time are already possible, right? So there will be, I assume, some bigger system which will be managing those, for example, robots on AGVs, right?
There are, at least from my experience, 2 options for this to address this challenge. First, you mentioned about to identify the parts and so on. We definitely need some eyes for the machine, talking about vision and so on, so they can identify what part should be taken and so on. On the other side, you mentioned about the movement and navigation of the machine. So this can be implemented directly in the cobot or in the robot,
right?
So they can know what is happening around and again identify the potential obstacles and so on. So I think that those 2 options are currently again available, and you can achieve what you mentioned, to find the parts, move autonomously and so on.
Okay, so I think in general, even looking from the perspective of the AGV management, yes. So AGVs are already a type of autonomous vehicle, which is, it's in the name, but it's moving in the factory.
Right.
And those devices will not work without a software package that is coordinated their work. Yeah. So we can expect that with fully autonomous production, with robots on AGVs, with all of these flexible working cells, this kind of management software that is, aware of the positions of all of the devices will have to be implemented together with those solutions. So that's probably the case.
This is a good point, because what we see also currently in the automotive industry is that you have isolated, processes or some, as you said, software for this process, this application, and so on. Sometimes we still miss this, as you mentioned, global coordination. So you have everything embedded into one software. So you have one global view on all your machines, what is happening. And this is also, I believe, the next step to go in the same direction, beside the points I mentioned about self-adaptive robots and so on. Of course, this is very, very important and a key, I think, success for this to achieve this autonomous manufacturing.
Perfect. I think we have still time for the last question, so we will be slowly wrapping up. But I can see the question still about this example that you provided about the rotor shafts for EVs. So the question is, I think it's a valid question. Again, what was the input data that we were giving to the learning model? What are these parameters that were necessary?
I will answer by your question. If you as a customer have this competitive advantage, would you be happy that I disclose that to your competitor?
Probably not.
That's my answer.
Okay, so that's something that I guess we could discuss on briefly using some sort of a discussion about specific production process. With maybe we can give some advices and so on, but we cannot disclose this kind of information because it's of course quite fragile.
Very, very sensitive. It's similar to the previous topic I mentioned about this European car maker. What we achieved. They have a strong competitive advantage. It would not be fair if we disclose this what exactly has been achieved. Of course, we are happy to cooperate with all our automotive partners, but those are very sensitive topics.
But I think it's worthwhile to say that I think the data science technologies that are already available, they are flexible enough to handle many different types of applications. And the input data for learning models, this is something that we can support our customers with. So we can help them to identify those most important parameters, I believe.
Exactly, that's a very good point. Even if we not duplicate exactly the same model from one partner to another, the idea is to work together, as I mentioned several times, working really together to identify those data endpoints, what would be important.
Right.
And this is how we can achieve, I assume, same results, or maybe even better. Clear. But this is definitely one area where we are happy to cooperate and support our customers.
Definitely, yes. You have contact to us. We will be sending you information with contact details, especially to the regional offices, so we can discuss this. In the meantime, I believe we will finish. So it's Friday. We can start thinking about weekend a little bit. And I hope you enjoyed our first podcast, first of many. Thank you, Lucas, for being here. And I hope I will see you sooner or later in the next episode, I hope.
Thank you, Piotr, and thank you, everybody, for listening to us. And yes, we have definitely many other topics to address together.
Thank you very much, and see you hopefully next month.
Thank you.